Hello everyone, Paul here from Fixing Foundations. Today we are going to be talking about simplifying radical expressions. And just to go through a quick review, in the last video we talked a little bit about perfect squares. So any whole number multiplied by itself will create a perfect square. So the numbers 1, 4, 9, 16, 25, 36, 49, 64, these are all perfect squares. And if we want to take the square root of a number, basically all we have to do is find the number that was multiplied by itself. And this gives us the square root. At least this is normally how we simplify them. If we have a number that is a perfect square, that is the simplification process. We just find out the number that was used, that was multiplied by itself to get the number in that perfect square. But what if we had something that wasn't a perfect square within a radical and we wanted to get the answer? So let's say we had something like, we wanted to find the square root of 48. How would we do this? Well, we could put it into the calculator, and if we do that, so if we put the square root of 48, it's going to give us a decimal. And a lot of college professors don't really prefer that you give the answer this way. They want you to simplify this expression in the way I'm going to show you now. And the way I'm going to show you involves taking out the largest possible perfect square that you can as a factor. So in this case, for the number 48, the largest possible perfect square we could factor out would actually be 16, because we can multiply 16 by 3 to get 48. And when we do that, we would express it like this. So we'd keep the square root sign, I'll make it a little longer, and then we would write 16 times 3. And we've created an equivalent expression here because 16 times 3 equals 48, and we've left it all into the radical. But what we want to do is we actually want to take 16 here and bring it out of the radical. And when we do that, when we move it from here to here, it's going to become 4 because the square root of 16 equals 4. So to write down what we have now, we're going to change that 16 to a 4. Now we're going to put it to the left of the radical. And we have 4 there, and then we just leave 3 in the radical because it does not have to be further simplified. We cannot take the square root of 3. So we're just going to leave it in there. And then our final answer is 4 root 3. Let's try another example. Let's say we had to get the square root of 50. How would we do this? Well, we would go through a similar process. We would ask ourselves, what is the largest possible perfect square that we could take out as a factor? And in that case, it would actually be 25 because 25 times 2 equals 50. So we factor out 25. So we'll leave the radical like this. We'll write 25 times 2 because 25 times 2 equals 50. And then when we move this out, when we move the 25 out, we are going to take the square root of it, which is going to create 5. So simplifying that, it would be 5, and then we'll write the radical here, and then we'll leave 2 in it because 2 cannot be further simplified. And our final answer is 5 root 2. Now what if we wanted to get the square root of 180? Well, let's do that. So again, we would find out the largest possible perfect square that you could take out as a factor. And in that case, it would be 36. because 36 times, let's see, actually, sometimes it's good to get a little bit of help from your calculator. So you could just try stuff. So if we were to take 180 and we divide 36, I think that's going to give us 5. But just to show you, and just because I forgot it for a second, yes, it actually is 5. So we're going to rewrite the radical, and we're going to write 36 times 5. And now we move this 36 out onto the other side, and when we do that, it's going to become 6 because the square root of 36 is 6. So then we write 6 here, and then we leave 5 in the radical because that can't really be simplified any further. And our final answer is 6 root 5. Now sometimes you'll be given examples of this that can be a little more complex. So let's say we had 4 root 75. How would we simplify this? Well, again, we would try to factor out the largest possible perfect square that we could from the radical first, or perhaps I should say the radicand. In that case, that would be 25. So we'll just write 4. We're not going to touch that just yet. And we'll expand the radical a bit. We'll do 25 times 3, because 25 times 3 equals 75. Then we'll move this out, right? When we move it out, it becomes 5. But there's a 4 here already, so what do we do? Well, what we would do is we would take that 5 and we would multiply it by the 4. So now our expression becomes 4 times 5, root 3. And then we just simplify that. We multiply 4 and 5. That gives us 20. Root 3 stays the same, and this is our final answer. I'm going to give you one more example, and I want to show you what would happen if you actually did not factor out the largest possible perfect square. So I'm going to write 4 root 320. And let's say, well, the largest possible perfect square that could be factored out of this is actually 64. But what if you didn't know that? What if instead of doing that, you factored out 16? Let's see what happens. So we're just going to see what that would be on the calculator. So we take 32, we divide this by, or 320. We divide it by 16. I think that's going to give us 20. Yep. So let's say we had 4 root 16 times 20, right? We could take this out because we could take the square root of 16. That's going to become 4. So then we get 4 times 4, and then we'll just leave the root 20 here. We would just, I'm going to start working downwards. We multiply these so that we would get 16 root 20. But you'll notice that we can actually take out another perfect square from 20. We can take out 4, because 4 is a perfect square. So let's do that. So we'll take out 4, we'll expand that to 4 times 5. Then when we could take this out, it's going to become 2, because 2 times 2 equals 4. And then we'll wind up with 16 times 2, root 5. And then finally we would get 32 root 5. This would actually bring us to the same answer we would have gotten if we had just factored out 64. Just in case you don't believe me, I'll just show you what that would look like. So I'll change colors. So ideally what you would want to do is factor out 64. So like you do 4 root 64. I think that's going to just leave 5, right? Because if you divide 320 by 64, yeah, it gives you 5. So 64 times 5. You take the square root of this, that's going to give you 8. You're left with 4 times 8 root 5, which brings you to 32 root 5. And we basically have ended up with the same answer. So try to take out the largest possible perfect square that you can, but if you mess it up,
it's usually not a big deal. That's going to do it for this video. There are examples where variables can get involved, but I wanted to keep this tutorial pretty simple. I will cover that in another video, so if you start seeing things like a squared or b to the fourth power within radicals, I'll show you how to take care of that too in the future. And I'll post that video in the description. I'll put a link to it in the description when it is ready. So feel free to check for it. If it's ready, you should be able to find it there. In the meantime, thank you very much for watching this video. If you enjoyed it, please leave it a like. If you would like to see more tutorials related to mathematics, please consider subscribing to my YouTube channel. And if you're interested in online tutoring, check out the description of this video. You may find something helpful.